It is working. That's great. I'm going to welcome up three phenomenal people. We've been having some amazing conversations, and I'm looking forward to sharing some of those conversations with you today. So I want to welcome up to the stage Donald Stevens from Chase. Come on up. Wendy Ju from Cornell Tech. Come on up. And Jorge Ortiz, come on down. You're next on The Price is Right. Join us here on stage. I'm gonna do something. I'm an academic, I'm sorry, and these people are pretty impressive, so I'm gonna start right here to my left with Jorge. Dr. Jorge Ortiz is an assistant professor of electrical and computer engineering at Rutgers University and the PI of the Cyber Physical Intelligence Lab, also known as the Sci-Fi Lab. That's a pretty cool name. He joined Rutgers last fall in 2018. Before that, he was at IBM. He has about a dozen patents, dozens and dozens of articles, and he is working on a number of different applications he's going to tell us about. MIT and Berkeley, and we have a little rivalry here on stage, so I'm a little nervous about that, because to his left is Wendy Ju, who graduated from Stanford University, so I was nervous about them talking earlier, but they seem to be getting along. She's an assistant professor at Cornell Tech. That's on Roosevelt Island. It has been open for 30 months, we established earlier, 2.5 years. She is in the information science field and runs the Center for Design Research, where she came from was the Center of Design Research at Stanford University, and was the executive director of Interaction Design Research from the California College of Arts, and she was an associate professor there. Her work is on human-robotic interaction. We're going to learn more about her work in terms of autonomous vehicles and how humans and autonomous vehicles are starting to interact. She has over 100 articles, a book, and many other accomplishments to her name. And to her left is Donald Stevens. He is the executive director at Chase. He is in charge of quantitative modeling team with consumer and community banking at JPMorgan Chase. Manages a team of analytical modelers focused on applying advanced machine learning and artificial intelligence techniques to solve business problems. Prior, he was at Moody's Analytics and ran their research division and working on head of operations research there with responsibilities for projects in applied math, operations research, data science, machine learning, quantitative finance. He has degrees from Sacred Heart, St. John's, Columbia, and Stanford. So you two hopefully will get along. We have this crazy title of this panel. So I want to do a little bit of definitional work. The panel is titled DARQ Matters, D-A-R-Q. This stands for, or pulling this apart, is distributed ledger, artificial intelligence, extended reality, and quantum computing. I don't think we're going to get to all of that all at once. Jorge, can you tell us a little bit about artificial intelligence and some of your work with IoT and how you're integrating these things?
Sure. So, my work is, I guess in the last few years has been called IoT. Before that, I think in the academic world, it's sort of still referred to as cyber physical systems. Mm-hmm. This is the integration of sensing in the environment, and the components are basically sensors inside the environment, people interacting with those sensors, and the intelligence being somewhere in the cloud or maybe in some cases on the devices themselves. The artificial intelligence part or the machine learning part is really in taking the signals that are being collected from this interaction to try to both optimize some system level things. So for instance, keep your building energy efficient, but also doing it without basically pissing off the people who are using it. So we focus, at least in my work, we sort of in our lab we focus less on understanding the human, knowing that they're part of it, and focus on making the machine learning part of it very robust. So collecting the data, making sure that our inference is robust across different environments. But I'm becoming a lot more aware of the actual human side of this. And so I was actually very excited to have this conversation right before we came up to hear more about expertise in that area.
And let's hear from let's hear from you, Wendy. Tell us a little bit about what you're doing with extended reality and that human part of the human-computer interaction.
Yeah, so the focus of my research is looking at interaction with automation. So there's a lot more interactive systems. Most of you probably have phones. And one of the things that's happening when we have these interactive systems is the behavior of the systems changes and adapts as we go. And this will become more the hope that will happen more when we have the more artificial intelligence and learning systems. And really what I'm focused on is that this presents huge challenges for design. Like in the panel before, a lot of people talked about engaging communities and finding out what people want. But what people want changes over time, and systems are changing over time. And so in some ways, we have to think a little bit about how we can design for this future where the products and the people are changing all the time. So I really basically use extended reality to simulate different interactive futures. For example, thinking about how people are going to interact with an autonomous car. It's expensive, it's possible, but it's expensive to get an autonomous car. And if you get an autonomous car, it's just programmed one way. But it's really easy to build a fake autonomous car in a VR system, or even put people out on the road and have a augmented reality fake autonomous car come up, and you can see how people will really react in what feels real, and then you can actually design around people's behaviors because you've kind of elicited what they will do in these different situations. So I know a lot of people who work on extended reality are really focused on gaming, which is super fun, but I'm really interested in thinking about different possible futures when we look at extended reality.
Very cool. So we've heard a little bit about smart buildings, and we're going to talk about health as well, autonomous vehicles, transportation. How does this fit into the financial world? Where do you see some of this technology, some of these dark matters finding their way into the business world at Chase?
Sure. So these technologies are very transformative. Some people would even say disruptive to a degree. But if you think about dimensions such as the economic impact, social impact, privacy impact, these technologies may have impacts at different degrees along those dimensions, right? So we think about economic state, there's always a fear of, will advanced AI and advanced ML, will they'll displace jobs, right? And how should we think about it? And you're probably seeing now in news media that even the concept of robots are impacting wages and earnings moving forward. And we actually don't even have robots actually sitting in the job market today. Or even when you think about social impact, right? So we know from history that law always takes time to catch up to changes in technology, right? Any technology you could think of. If you look back even in the form of criminal trials and DNA, at which point did the law catch up to allow DNA evidence in trials? So as we think about AI and ML, imagine that computers are making more decisions. How quickly do we need the law to kind of catch up to that to affect the sort of social ramifications of that? Or if we start allowing AI and ML to view the behavior of people, so if you think about recidivism is basically, historically, what is the probability or the possibility that someone who commits a crime will repeat a crime? And when we tried modeling this behavior without ML and AI, what we saw was that there's so much bias in that data, right, because of historical minorities based in that sort of population. So we've now turned this behavior over to machine learning AI, are we then going to see similar sort of behavior and bias? And I think the last one is really privacy. And when we think about privacy, it's really how much information do you want to give up? And if so, do you know you're giving it up, and do you know what you're getting in return? So at Chase, we have to kind of balance all of these sort of aspects so that we can make sure that we're using ML and AI in a proper way so that we're improving the experience of our customers and our employees, but not causing so much of an issue that we're actually causing issues for them and detracting from their sort of financial social responsibility.
Great. And I want to come back to health and thinking about the challenge. We heard earlier about the number of cars. There are 8 bridges into Harlem. That's a lot of particulates. That's a lot of smog-forming particulates here. What's some of the work that you're doing around that might be addressing some of the social concerns? But also, if we're monitoring every car coming in and out of Harlem, that could be a privacy concern, right? So, how do you think about some of those challenges? Maybe just tell us a little bit about the project that I'm alluding to.
Yeah. So we're starting a project now where we're designing these cheap sensors that folks can carry around with them as they move around their neighborhood, coupled with sensing in the environment now through this Cosmos testbed, so that people have a much better understanding of their personal exposure to particulates in the air, things that are bad for their health, things that may make asthma worse, or over extended periods of time could develop other sorts of respiratory and cardiac diseases. The challenge, obviously there's lots of technical challenges to enabling this and keeping costs low, and I think on the engineering side of things, that's been most of the focus. But we're now working both with Silicon Harlem and starting a partnership with WeAct so that we can better understand the needs of the community as well. And for this not only to yield interesting technical challenges for us to work on, but to actually have impact on people's lives, right? And for that not to go away once the project is over. So there's this big challenge for us to sort of engage with the community in a meaningful way so that it informs how the technology is designed.
I want to challenge you a little bit there. Mm-hmm. Jackson Heights, Harlem, these are not homogeneous populations with, everybody in Harlem's the same. I mean, I've spent enough time in Harlem to understand that Harlem has an incredible array of different people. I've spent a little bit of time in Jackson Heights, 160 languages spoke. How do you engage a community like these diverse, dense, urban areas we have in New York?
So, that's an interesting question for me in particular. So I grew up in Queens. I grew up in the kinds of communities that you see around Harlem. I know that there's a fundamental distrust. I know that I'm now seen as a figure of authority and someone they probably shouldn't trust, right? Because they might think, oh, well, you're just using us for whatever. There may be this misunderstanding that we're just going to use them to get their data and we don't really care about what's going on there. So I think this is where those community partnerships play a big role. And frankly, I can speak from it from a first-hand account, but I can't assume that my experience is the experience of an entire community of people. I may understand a little bit better where some of that distrust may come from, but I think working with community organizations that have built trust over many decades, and always modulating my designs through them or filtering it through them, I think is, first priority aspect of this project, which makes it very different from the types of engineering projects you might typically see in regards to the use of AI.
Wendy, you talked about participants driving extended reality vehicles in New York City. How do you get participants to get engaged with your research? Can you tell us a little bit more about what you're doing on Roosevelt Island, and kind of how do you attract and bring people in to get different perspectives and engage in some of the diversity here in New York? So you're not just getting one type of participant, right, sitting behind the wheel.
Well, I mean, I moved here in January 2018, so I've just gotten my lab up and started. So we do different kinds of research. Some of the work that we do with extended reality, for example, is lab-based research. We have people come to Roosevelt Island and get into, I have on the third floor, I have a car inside of a room on the third floor of the Tata Innovation Center. And they basically drive in what feels like a real car, but is just an extended reality situation. And right now, I mean, one of the things is a lot of the methods that we're using are new, and there's a lot of criticism in the scientific community for how many studies are really run with students as populations. So we are making generalizations about all people, but really all those studies are really studies of students and university students. So university students are not like all people. But from the other side, if you don't know if your method works, working with people who are well educated, know to show up on time, know how to follow directions, making sure your method works before you engage with community is really important so you're not wasting everyone's time. So we have some studies that we've run, for example, looking at automatic intersection management with students, and then we're actually now at the point where we're trying to get people from different communities to look at how they would feel if they were in an intersection where there were no stoplights and the cars just communicated with each other and they just went. It could make things more efficient, like there would be less particulates because there's not all this stopping and idling, but it feels awful. And so figuring out how close the cars can be to each other, how fast they can move and still make it feel okay, and in which neighborhoods, if there are different norms, like that's really important to us. So we're kind of, reaching out to different places to understand how people in different places feel.
So if folks wanted to join, they could find you
I should have brought a
afterwards?
slide with cards.
Okay.
But if you look, I'll put a link up on my website. I'm wendyju.com. We basically are recruiting participants for our experiments.
Very cool. So what are some of the advantages you're seeing in the financial sector? What are some of the things that are helping Chase solve business problems with some of these technologies? And how do you maybe trial those or pilot test those, and kind of how do you test these things out to say, is this really going to work? Is this really going to benefit our company as you're rolling out some of the machine learning or AI techniques that you're working with?
Sure. So maybe I'll start off by just describing some of the ways we've already implemented machine learning AI. So one of the most common ways that won't be a surprise to most of you is fraud detection. If you think about fraud, not that I'm assuming that any of you commit fraud, but if any of you have a Netflix account, if, for example, Wendy were to give her credentials to Jorge, Netflix will start to think that the movies that Jorge likes is actually Wendy's movies, right? So what Netflix is doing, Netflix, what they're doing is they're looking at the types of movies that's being watched so they can make a recommendation for the next movie. But it's basing the profile on the user ID, so it actually doesn't understand the distinction between Jorge and Wendy. Now imagine that we move that scenario to credit card transactions. If I wanted to defraud someone, the most logical thing for me to do is make my purchases match the purchases of that person. And that's a way to be under the covers of any sort of detection. So what you need is ability to monitor fraud live in the sense that as the patterns change, the abilities of detection changes. And that's the benefit you would get from machine learning AI, these systems that are self-learning. Now the question is, how do we control what they're learning, and then how do we teach the computer to do these things? Now I think Wendy touched upon that point in the sense that you mentioned your students. What you often find is that you always start with some data or some population of people. So everything you do as a result of that is really based on that starting point. So if someone's not included in that starting point, well, what is the effect later, right? So if I have a group of people and I have all males and I have no females, then whatever I come out with, what would be the impact to females? So we're very rigorous in the sense of trying to understand what data elements we use. We try to avoid anything that we consider to be legal characteristics. So things such as sex, age, personal family dynamics, number of children, and those sort of things. Some of those are legally protected, so we're not allowed to use those. We're also very socially responsible on some new data elements, such as social media data, right? Should I be gauging Wendy's behavior based on her Facebook behavior, right? Or should I be viewing Jorge's behavior based on his relationship with Ryder, right? So we're mindful there. And then lastly, we go through a rigorous sort of validation process. So it's kind of like a live sort of acceptance testing sort of criteria. It's almost as if you build a new car and you're having people test drive it to see if it works. So what we do is we do a pilot program with these capabilities, and over a quarter or two, we monitor the effects just to make sure that we've controlled for bias and just to make sure we control for the customer experience. And we learn from that and then do another iteration to make things better.
And how do you test and validate and understand if you're getting the answers out of machine learning and AI that you expect or don't expect? And if you don't expect an answer, how do you still think it's the right answer? I mean, you're both wrestling with this question, right? I think you're probably also wrestling with this as well. So, how do you validate something where you put things into the black box, you get answers out? It's not a linear process here.
But Ryder, we should also keep in mind, right is actually not a well-defined answer in this space. So you think of right, sometimes we think of right and wrong.
Sure.
But in actuality, it's a spectrum of
the probability.
That's right. Well,
So tell
I
us
didn't
about
want to
it.
get too technical on that, but I'll let Jorge answer this one. But what you often find is that things that we do in this space is very subjective. So what is right is questionable. It's almost asking if a person makes a decision, how do you know that decision's right? And a lot of the time you'll look at the outcome or the impact of that decision. But I just want to set that focus so that when Jorge answers this question, we understand right is not necessarily right all the time. It's very subjective. And you actually have to look at the elements and details of what you're looking at to determine if that decision is actually the best decision.
I actually have a great example of that, if you don't mind my jumping
Please,
in.
yeah.
You know, so autonomous cars are really amazing right now, and they drive right in that they don't like willy-nilly run people over or go sideways into buildings. But if you actually are around, and in New York they don't let you test these things on the street, but like in the Silicon Valley they do. These cars that they have driving autonomously actually get into more accidents than other people. They're not at fault accidents because they drive really slowly and super cautiously, and they wait till they understand everything that's going on in an intersection before they go. But because of that, they get rear-ended at 10 times the rate that people do. So the people who are from the company say if the car is driving legally, you know, it's not at fault, so it's right. But if you ran into somebody, you would normally feel guilty. But if you found out that person you ran into gets run into 10 times more than someone else, it would start to seem like a problem. And I think this is a thing, like the cars are driving correctly, but not normatively. They don't drive the way everyone else does, and it causes more accidents. And if you were basing your decisions on like what's going to cause the least amount of accidents, that would be a really different answer. And that is the kind of thing that we're grappling with right now. Like, in different neighborhoods, the right way to drive is a really different thing, and that's an incredibly difficult thing for a machine to understand.
So I think that's an excellent point, and actually that reminds me of some of the work that we've done in smart buildings. The occupants of every building are different. What makes them comfortable is different. It could depend on the whether it's cold outside, how much clothing they have on. What kinds of activities are taking place in that building. And this is the same sort of thing. It's, if you're from an environment, so for instance, in Japan, they might be more willing to be, there's a cultural component. In Japan, they might be willing to be more uncomfortable to save energy. Whereas in the United States, we're a little bit more aggressive about making sure that the system is working for us, not us cooperating with the system. And so the way we typically test what's right or try to understand what's right, historically there have been well-defined notions of correct behavior, and that's totally changing now. So now it's let's discover the context, and within that context, what's normative, and then try to approximate normal behavior given that context. And you build different models as you go from one building to the next, from one environment to the next, as you deal with different mixtures of people, gender, age, whether it's a nursing home or a university environment, and all of these things both. So on the IoT side, we're measuring the environment and trying to infer that mixture, and then relearning the context so that we can set what right is. And right just means what are the people doing? Because they tend to converge over time on right behavior.
So I've been listening to this, and I've thought about a time I stopped at a stop sign and I got rear-ended, and the guy behind me got out of the car and goes, "Nobody stops at this stop sign." And I thought, oh, I guess I don't live here. I'm sorry that I didn't recognize that that's not a stop sign in your community. And then I'm thinking about every time my wife tells me to put the sweater on instead of turning up the heat, and I've gotten plenty of notifications from banks in terms of like, did you just buy this? And I'm like, yeah, I just bought this. You got a problem with it? Like, I mean, it's like, oh, maybe I don't usually buy that. Am I acting irrationally right now? I want to invite you into this conversation and allow you an opportunity to ask questions. So I'm going to stand up, walk around. Please feel free to raise your hand. I will be there in a few seconds, and I'll get right to you. So does anybody have any questions for the panelists? Yeah.
Yeah, so as we move in this world of what we call hyper-normalization, and we're blurring the lines between right and wrong, and it creates confusion somewhat. So how do we reconcile this now with AI and having machines come into this realm of the human behavior and the human element that we have to insert.
So one thing is that people, this world where there's different definitions of right and wrong has always existed, right? More the issue now is that we're designing products that have one policy and they're trying to use that same policy everywhere. And the fact that the stopping distance, for example, in Harlem might be different than on Roosevelt Island, that now suddenly is a problem in a way that it wasn't a problem when it was just people doing it. So what people do when they encounter strangers is that there's all these normalizing processes. We have different ways of signaling to each other and negotiating with one another to help one another kind of do the right thing. And that's something that machines need to learn to pick up on. So I know there's been emphasis on thinking about how to teach people to code, but we're also in an era where the original code is not really going to define how things are going to behave, a year, 2 years, 3 years, after deployment. And so thinking about how we train and negotiate, interact with systems is going to be very important. And it means we have to build systems that can respond to the things that people are just going to do to normalize behavior.
We have another question right here.
We keep talking about normalizing behavior, but we haven't been able to get human beings to differentiate and to decide what is right and wrong and what is, especially for race or gender. How are we going to be able to teach machines that everything is contextual? So whatever they learn, there is a way that it can be wrong, even when it's right, for a different person.
Yeah,
So this is like treating, like the golden rule is treat others as you would like to be treated, and then the platinum rule is find out how people want to be treated, right? And this is, sorry, Donald.
No, that's really important. I wanted to touch upon the last question and something Wendy said. So, and I think this is to your point. What we see in modern human behavior doesn't drastically change than what we saw in history, right? And we're always trying to account for that. And the fear is, are we then going to bring our own experience back into the computer world and then make the situations worse? The first thing I would say is I would challenge everyone to think about what do we mean when we think of experience and what do we mean when we think of bias, right? So statisticians and mathematicians and everyone, they'll always have this view on bias. And sometimes you hear bias is good, sometimes you hear bias is bad. If I speak to a select few of minorities or blacks, Hispanics, and so forth, they'll tell me bias is bad. If I then ask them questions about experience, they will then tell me experience is good, right? So what would it mean if I never interacted in my life with maybe a Hispanic person, and if for the very first time I interact with that person, I had a negative sort of interaction? Experience may make a person think the next interaction there's a more of a safeguard or more of a backstep. So we call that human experience, but human experience says, well, you should never judge the group by your interaction with one, right? It's multiple interactions. Or with regards to my relationship with Jorge, what about with somebody different in that spot, right? And that's what we're worried about when we do computers. But the reality is, it's not a problem we solved as people. What we have to do is we have to be mindful of what we're seeing that the computers do. And the interesting area of AI research actually helps us understand how we as people react and how we as people think. But the reality is we actually don't know why people make certain decisions they make, how they make certain decisions they make. I'll give you a very prime example. I'm assuming everyone here knows how to type, right? If I ask each of you to hold your hands in the air and press the letter Z for me, most of you have problems thinking about it, right? Some of you, I saw some people throw up 2 fingers, but some of you would have to spend some time thinking about it. But if I just put a keyboard in front of you and just asked you to transcribe every word that I'm saying, you could do that with no problem. It's almost like a second instinctual nature, right? You just know how to do it, right? So that behavior is something we're trying to learn, but I agree with you. It's not easy to say that we're just going to take these approximation algorithms in math and solve away every sort of social problem there is with the computer. In reality, the computer may just already learn and show us our own behaviors, right? But that's something as a society we still need to resolve.
One last question.
So how do you how do you take into account for quantum coherence? Oh, sorry, I'm not going to ask you about quantum. So, so
Your simulation is the answer, but I don't know what.
so much of what you're talking about, these are things that are sort of norms that are decided on a community by community basis. And it seems like so much of what you're talking about are things that are being worked out in corporations or universities, and where do you see community coming in and playing a role and deciding on governance and setting some of the rules? Where do they get a say?
You worked in building. You must have something to
Yeah,
do.
no, I mean, and I'm going to be honest. Like, look, these questions I think are extremely important, no question. I think about the problems that we're working on and the notion of right. So there's two sort of observations I make. One is the notion of right and wrong is fundamental and very hazy. We built this smart pill box. It has a bunch of sensors on it. We just want to tell if my grandmother was taking her medication. What if she didn't want to? What if that's how she wanted to go? What if she just didn't feel like taking it and she'd rather, for her, that was a better quality of life to not take her medication? I question this personally in thinking about the design and the whole goal of creating a smart pill box to make sure my grandmother was taking her medication. It's not an easy question to answer. That's the first one. So this is pervasive. It happens at a small scale. It happens at a large scale. The second one is it starts to get very dangerous when you're making the same kind of decision I'm making with the algorithms I'm implementing to see if my grandmother took her pill, but you're doing it on a societal level to decide whether someone should spend a longer time in jail. Just the scale of that is enormous. And there I think it starts to become critical to have something that people are comfortable with and get feedback directly from people about, listen to the community and try to translate that into something that the society at large can be comfortable with. Because the scale of it is the scary part, right? I think that's the thing you have to be very dangerous about, that you have to be very careful with.
I think we like to engage with community organizations, do these town hall things, and the conversation with the community only works if the community has some understanding of the technology or the decisions that are being made. And so there's a huge need to actually make these difficult and new technologies comprehensible. But I also think about, it's New York. If you go to every single community event and you engage in every town hall, you haven't engaged with all of the tourists that come through the city. And, I know we sometimes are not sure, but tourists are people too. And I think so a lot of how behaviors get defined and negotiated happens right there in the moment on the street. And so thinking about what literally the person on the corner sees, for the wireless test bed, technology, for AI technology, for fraud detection, what is made apparent to each person is actually a really important ethical issue, because those things, you might say you want one thing, and in the moment you think of a context or a reason or something, like a reason why you should take this certain medicine today. And if we don't actually open it up so the technology can receive some of these messages, we won't get them. And you know what it's like to negotiate with a toddler. Negotiating with a technology where there's no input is a really impossible thing.
I just want to close out that question with one other statement. We should never take the presumption that these activities and machine learning AIs be done in isolation, right? What I would say is I would encourage everyone of every background to kind of learn some of these capabilities and be part of that sort of conversation. I always think if someone has a seat at a certain table and they have the influence to move that discussion around and to guide what the next step of that discussion is, you have a much better ultimate outcome in terms of how things are getting used and how things are learned. In the AI machine learning arena, it's not only the technical development and the math and the statistics, but it's also the impact that we need to focus on. But the only way to do that is to make sure it's an inclusive conversation, and it's a conversation based on lots of different dimensions and lots of different experiences.
So with that, I want to say thanks everybody for being here, for listening, for participating, asking really good questions. I want to thank our panelists for coming and joining us today. Thank you all very much. So.
Ryder, that was great. Fantastic.
Thanks,
Thank
Richard.
you so much.
Absolutely.
Thank you to our panelists as well. I'm going to try to turn this on, see if it works. Hello.